Hello everyone, we are Soc Security Project Group. Mahima and myself are both first year CE master students and have industry experience in hardware design. Most of the modern technology is based on system on chip or SoC. These SoCs are host of numerous confidential information which needs to be protected from unauthorized access. This project aims at securing the system by extending its architecture to include secure interface to interact with the outer world. This also helps evaluate the threat of having hardware accelerators. This is system on chip we are using for this project. It is called CEP or Common Evaluation Platform. Dark blue boxes are hardware accelerators which come from different vendors. These crypto cores stores a key, and it is really important that this key is well secured and accessed by the authorized entities. There have been examples where this was not configured correctly. So we are trying to make a system that mitigates this issue and help the core to securely initialize, configure, and connect. These hardware accelerators do not have direct access to memory. Instead, the processor transfers the data from them. This type of indirect access can make a system very slow. So a simple solution would be to let these cores directly access the shared memory. But this introduces a problem of security threat. That's the reason for adding an AXI bus to control this interaction, which is solution to both the security threat and latency. If any of the hardware accelerator try to access a restricted memory region, the AXI master can monitor that and send an error. Highlighted portion in green was the project proposal, that is to develop and integrate the AXI machines to control and monitor the hardware accelerators. Our main work focused around making the AXI master machine better. So we extended one hardware accelerator, which was MD5, with high performance AXI 4 master interface. This master allowed independent memory access to MD5. We used the AXI Lite slave interface for MD5 and processor interaction. We developed the register access mechanism for processor to control MD5 core. Also based on these registers, we configured AXI master and control its interaction with MD5 core, which is also called Pancham. I have taken a very simple test to explain this handshaking. Firstly, we will configure these registers from AXI Lite slave. Reg 0 is used for master activation. Reg 1 holds the source address and Reg 2 holds the destination address. The address of Reg 0, 1 and 2 are 0, 1, 2 respectively, and data they are holding are 1, ABCD, and F0, F0. In second step, the AXI master reads the register 0 and activates itself if its value is 1, and further reads register 1 and 2 to know the source and the destination address. Master uses the source value ABCD and reads its data, which is FEDC, and write it to the input buffer. This input buffer is driven to the wishbone interface and then to Pancham. Pancham returns the hash value to wishbone, which is written to the output buffer. The value here is FEDC, as other bits are padded to 0 for now. Further read by the AXI master and written to the destination address F0, F0. Let's see similar result in waveform. So the first step was register development and register access mechanism. We see here that these registers are successfully written by the slave interface. Reg 012 having address 012 and data 1 ABCD and F0 F0 respectively. We see how test bench drive the slave interface to configure these registers and then further reading the value from the slave whether configured correctly or not. This step is AXI master development and master activation. We can see that Reg 0 is 1, so master is activated and it further reads register 1 and 2 to know the source and destination address. The last step was AXI master and MD5 core interaction. The AXI master reads the source address and write it to the input buffer, which is further driven to the wishbone and then to Pancham. Pancham hash output value returns to wishbone, which is further written to the output buffer. Master reads it and write it to the destination address. So this is our final execution. We developed the AXI 4 master, added register access mechanism, and interacted through the processor, AXI Lite slave, and MD5 core. Our delivered design will be adding feature in making this architecture secure by limiting the memory access. And since this is an ongoing project, development of other security features like your security policies and other memory access are still in progress. Working team will also try their developed security policies on our design. Thanks for watching.